Here we will consider three approaches to calculating probabilities. The first approach is the relative frequency probability, or oftentimes what we'll call experimental probability. And the reason we would call it that is because we're using the results of an experiment or using some data that has been collected to determine how likely an event is to occur. And the way it's computed is we look at the probability of an event A would be the number of occurrences of that event A divided by the total number of observations, or the total number of outcomes. If we're performing an experiment, maybe we would think of them as being trials. So the total number of trials or outcomes in our experiment. So looking at the example below, suppose we want to compute the relative frequency probability of this situation where we have 200 million people that are affected each year by malaria, and 600,000 of those people die. What is the probability that someone affected by malaria will die? So we can simply just look at the number of deaths that have occurred in this data, and then all the data that we're looking at in total. We have 200 million that are affected by malaria. Classical probability looks at the sample space to determine how likely an event is to occur. When we have a collection of equally likely outcomes, the classical, or sometimes we would call it theoretical, the theoretical probability of an event A is the number of outcomes in event A divided by, so looking at its sample space, right, the number of simple events in A divided by the total number of events in the whole sample space. So considering this example, when two children are born, what's the probability that both are the same gender? So let's think about the sample space here. You have two children, and either child could be a boy or a girl. So let's list out all the possible ways that we could have two children that are either a boy or a girl. In one case, we could have the first child is a boy, the second child is a boy. The first child is a boy and the second child is a girl. We could have that switched around where the first child is a girl and the second child is a boy, or the first child is a girl and the second child is also a girl. Now looking at these four possible outcomes, right, this makes up our whole sample space, and exactly two of those outcomes, boy, boy, and girl, girl, have the same gender. So we would have 2 out of 4 probability that in our two-child family we have the children have the same gender. Subjective probability is determined by making a guess. And in most cases, there is no way of computing these kinds of probabilities. Usually we have no way of knowing whether our guess is accurate or completely wrong. And in this example of subjective probability, what is the probability that the next dollar bill you spend was previously spent by Beyonce? Well, the best I could do here is sort of come up with a very rough estimate, and I really have no way of testing it or determining whether that estimate is anything close to the actual value. So perhaps the best I could say is that it's very unlikely. But if I wanted to compute a number value associated with this, well, it's almost perhaps a waste of effort, but it's perhaps an interesting problem to think about. How would we try and come up with an answer to that?